Hello everyone. Today I'm going to expand my conference paper, the targeted full-state injection attack against DC state estimation without the 9 parameters. Well, let's go to the first part, the introduction part. As it's known to all that power systems nowadays are subject to the cyber attacks due to the vulnerability of the communication networks. As an important class of cyber attacks, the full-state injection attacks can corrupt the readings of power sensors, thus causing the system operator to receive false measurements and then perform incorrect operations. Therefore, the state estimation is used to detect incorrect measurements, but it cannot recognize and eliminate the well-designed full-state false measurements injected by the FDIA. So in this paper, a novel full-state injection attack model against DC state estimation is proposed. Our method requires no network parameters and explores only limited phase measurement units. Meanwhile, the proposed full-state model can target specific states with large non-deviation using the estimate 9 parameters. So let's go to the background part here. So in the DC model, system can be represented as the linear equation below, Z equal to HX plus E. So the best state vector X hat should be this equation. Next, we have the bad data detection. So if the residue is larger than the predetermined threshold, then the measurements are considered to include the bad data. So for this paper, if we want to fool the power operators and estimate state vector is X bat instead of the X, then we need to replace the original measurement Z with the Z bat here. So the question here is how could we design the Z bat? Now here's the methodology below. So as it's known to you that the node powers are naturally experience fluctuations. So we make the common assumptions that load powers are perturbed by the independent Gaussian variation from their static load, as is shown in this picture. So by linearizing the load equation around its steady states in the attacking region, we can obtain a matrix form. So in which the value of state sigma can be obtained by PMU measurements. Next, the system matrix A corresponding to a scaled Jacobian matrix carries significant information about time constant and time parameters. So only relying on PMU measurements, after getting rid of the time constant matrix, intruders finally can obtain the 9 parameters for design of FDIA here. So the algorithm can have 6 steps. Step 1 is choose a target bus and determine the target region. Next, we need to collect voltage phasors and current phasors inside the target region. Third, we need to calculate estimate metrics. And next, we need to estimate the time constant and the 9 parameters. And finally, given the target and malicious phasors, intruder can design attack vectors. So as you can see here, the result here, we want to modify the state of bus 15. So the attacking region has three bus here. So after the full-state injection attack, you can see that the value of the angle 15 has been changed. Meanwhile, it can also bypass the bad data detection. So in sum, a novel full-state injection attack model against DC state estimation proposed in this paper. And based on intercepted PMU data, its full-state injection attack can target specific state without any pre-knowledge of 9 parameters. Thanks.